So for geometric sequences, a sequence or series is geometric if the ratio is constant. Ratio is multiply or divide by the same number every time. So you know that a sequence is geometric if it's like times 2, times 2, times 2 every time, or divide by 3, divide by 3, divide by 3 every time. So how to find a specific term or write a formula. If you're looking for a specific term, like the nth term, you would start with the first term, and then you multiply that by the common ratio with an exponent of n minus 1. So this is looking for the nth term. A sub 1 is the first term. R is your common ratio. And n is the number of term that you want. We'll do an example and talk about how to plug things into that. If you want to add up a certain number of terms in a geometric sequence, we call that S sub n, which is the sum of the first n terms. And again, we start with the first term. We multiply that by 1 minus r over n, or I'm sorry, r to the n, divide by 1 minus r. This would be the formula. R is still common ratio, n is number of terms, then a sub n is the first term. Last, how to find the sum of an infinite geometric sequence. We will do an example of one of those, but that would just mean a sequence that goes on forever. This one has like 21 terms. That's what you would use this one for. If this one has an infinite number of terms, you would use a different formula. And it is this. First term divided by 1 minus common ratio. So we will do an example here. Example 1 is find the common ratio, the 8th term, and the sum of the first 8 terms. So the common ratio is r, and it's the number that you multiply by to get to the next term. This is kind of a complicated sequence, so if it's ever not obvious what the common ratio is, what you can do is take a term like 9 and divide by the previous term. So in this case, 9 divided by 10 is 0.9. So my common ratio is 0.9. And that works by taking any term and dividing by the previous. That will give you your common ratio. 8th term. So 8th term, we would use this to find a specific term, and it's the first term, which is 10, times the common ratio, which is 0.9, to the n minus 1. And if we want the 8th term, it would be 8 minus 1, so it'd be to the 7th power. And if you type that all in your calculator, you get 4.78 as your 8th term. The sum of the first 8 terms, it's finite. We want 8 terms, would be here. And we'll take the first term, which is 10, times 1 minus the common ratio to the nth power, and is 8, because we want 8 terms, over 1 minus the common ratio. I'm just going to take all that and plug it in. And I get 56.95. So that's how to use these first 2 formulas. Now we'll do this one. Find the sum, and this sum has no end. It goes on forever. So if you're looking for the sum of an infinite geometric sequence, you would use this one. And the first term is 8, and it's 1 minus the common ratio. The common ratio is the number that you multiply by every time. So here it is getting smaller, so I can't say that I'm multiplying by 2, but I could say that I am multiplying by half every time to get the next term. So this would be 8 divided by half, which is 8 times 2 over 1, which is 16. And if you're doubting that, because it seems weird that you would have a sum for an infinite sequence, you can just start adding them up. 4 plus 8 plus 2 plus 1. We're at 15, and if I kept going, the next term would be half. 15 and a half, the next term would be a fourth. 15.75, and we are getting closer and closer to 16, so that answer does make sense.